doesn't have to mean unimpressive. Mercury, the smallest planet in our solar system, may sit at the bottom of the planetary size chart, but that doesn't mean it lacks fascinating structures or cosmic mysteries. In fact, this seemingly quiet world hides a wealth of incredible features. Thanks to modern space technology, we're now fortunate enough to explore Mercury's unique terrain from the comfort of our couches. But what exactly do breathtaking new photos of Mercury reveal? Why does its cratered surface resemble a cosmic version of Swiss cheese? And why do some scientists question whether Mercury is even a classical planet at all? Let's start with the basics. Earth's diameter is approximately 12,742 kilometers, whereas Mercury's is just 4,880 kilometers, making our home planet about 2.6 times larger. But the differences don't stop at size. While Earth is located an average of 150 million kilometers from the Sun, Mercury orbits much closer, just 58 million kilometers away. As the closest planet to the Sun, it's no surprise that Mercury is also the fastest. It zips around our star in just 88 Earth days, compared to the 365 days it takes Earth to complete one orbit. However, Mercury's orbit isn't a perfect circle. It's slightly elliptical and is affected by the intense gravitational pull of the Sun. While these minor orbital shifts may seem insignificant at first glance, over the course of millions of years, they could dramatically alter Mercury's fate. The planet could potentially be thrown off its orbit entirely, either plunging into the Sun or drifting into the orbit of Venus or even Earth. Fortunately, no such collision course has occurred yet, giving scientists more time to study this enigmatic world in peace. Speaking of studies, one of Mercury's most fascinating characteristics is its dramatic temperature fluctuations. Because the planet comes as close as 46 million kilometers to the Sun, daytime temperatures soar to an incredible 427 degrees Celsius. But when night falls, things take a frigid turn. Without a substantial atmosphere to retain heat, Mercury's night side drops to a bone-chilling -173 degrees Celsius. This massive temperature swing is caused by the planet's almost non-existent atmosphere, which allows the Sun's radiation to strike Mercury's surface unfiltered. As a result, the idea of sending humans to Mercury remains firmly in the realm of science fiction, for now. Due to these harsh conditions, exploration of Mercury has so far been limited to unmanned space probes. Only 2 missions have made the journey, Mariner 10 in the 1970s and NASA's Messenger probe, which ended its mission by crashing into the planet's surface in 2015. But the wait for more data is nearly over. The joint European-Japanese BepiColombo mission has been performing multiple flybys of Mercury and is expected to enter its final orbit around the planet in November next year, promising a new wave of discoveries. Even before BepiColombo's arrival, scientists already had access to detailed images of Mercury's landscape. One of the first things that stands out is how much Mercury resembles a moon more than a planet. Its surface is riddled with craters, evidence of countless cosmic collisions. These impact craters remain preserved due to Mercury's thin atmosphere, which offers no protection from even the smallest space debris. Unlike Earth, where many incoming objects burn up in the atmosphere, Mercury's surface bears the full brunt of every impact. Adding to the moon-like impression are the many radial patterns that radiate from the craters. These streaks mark the path of debris ejected during the impacts, as it gouged into the surrounding terrain. Similar radial structures are also found on our moon, which has led some researchers to propose a provocative theory: Mercury may once have been a moon itself, possibly a satellite of Venus that escaped its gravitational pull. The fact that neither Mercury nor Venus currently has a natural moon lends some intrigue to this idea, though it remains unproven. One standout feature on Mercury is the 15-kilometer-wide crater named Mina. What makes this crater especially interesting is its bright ray system, a pattern of light-colored streaks that spread from the impact site. These bright rays suggest that the impact occurred relatively recently in geological terms. Over time, these rays will fade and blend into the surrounding terrain, but for now, they offer scientists a glimpse into Mercury's dynamic history. Then there's the Beethoven Basin, a colossal impact crater that's 625 kilometers in diameter and up to 2.5 kilometers deep. Named after the legendary composer Ludwig van Beethoven, this crater is one of the largest in the entire solar system and is accompanied by several smaller craters, including the 140-kilometer-wide Bellow. Strikingly, the Beethoven Basin lacks the distinct ring structures often seen in large craters elsewhere in the solar system, making it a geological curiosity. But even the massive Beethoven crater isn't the largest on Mercury. That honor goes to the immense Caloris Planitia, an impact basin with a staggering diameter of 1,550 kilometers. Researchers estimate that the asteroid responsible for creating Caloris Planitia was around 150 kilometers wide. The force of the impact was so powerful that it caused seismic waves to travel through the entire planet, reshaping the surface on the opposite side. This seismic energy fractured and uplifted an area of 500,000 square kilometers, forming mountain ranges up to 1,800 meters high. It's one of the most dramatic examples of planetary trauma ever recorded. The 715-kilometer-wide Rembrandt crater, discovered by the Messenger mission in 2008, is another standout formation. It's the 10th largest known crater in the solar system and was missed entirely by Mariner 10. Unlike most of the formations we see on other celestial bodies, some of Mercury's surface features are entirely unique. For example, Mercury is covered in massive scarps, also called lobate scarps, that stretch for hundreds of kilometers. These features are thought to be the result of the planet shrinking slightly as it cooled. As Mercury's interior contracted, the crust buckled and formed enormous cliff-like structures. The longest of these scarps is known as Enterprise Rupees. It stretches over 400 kilometers and serves as a geological time capsule, revealing the incredible forces at work in Mercury's past. These scarps are crucial for understanding the planet's tectonic history and are unlike anything seen elsewhere in the solar system. Another eye-catching formation is the crater Apollodorus, located at the center of a vast graben system known as Pantheon Foci. Before it received its official name, scientists nicknamed it the spider due to the many radial cracks extending outward from the center, which resemble spider legs. Although it remains unclear whether Apollodorus played a role in the formation of Pantheon Foci or just happens to lie at its center, the resemblance is visually striking and somewhat eerie. Then there's the Tolstoj crater, named after the famous Russian author, which features a unique multi-ring structure. The crater consists of several overlapping impact basins, with two clearly defined rings measuring 355 and 510 kilometers in diameter, and a third incomplete ring around 465 kilometers. Despite its immense age, the crater still boasts a remarkably well-preserved ejecta blanket. This refers to the layer of debris flung outward during the impact, which now surrounds the crater. Interestingly, the relatively linear distribution of the ejecta suggests that it interacted with pre-existing surface structures, shaping the final appearance of the region. And let's not forget the Hemingway crater, another literary namesake, this time honoring the famed American writer Ernest Hemingway. This 126-kilometer-wide crater stands out from the rest due to its darker appearance, which is attributed to differences in the mineral composition of the surrounding rock. The crater offers researchers a chance to study the planet's diverse geology in even greater detail. As the BepiColombo mission prepares for its final approach, scientists and space enthusiasts alike are eagerly anticipating a new era of Mercury exploration. With advanced instruments and a longer observation window, we'll be able to unlock more of the planet's secrets, perhaps even discovering new clues about its origins, geological evolution, and its connection to the rest of our solar system. Until then, Mercury continues to be a fascinating puzzle, one that proves that small doesn't mean insignificant. From towering cliffs and ancient impact basins to mysterious scarps and dark craters, Mercury is a tiny world with colossal stories etched into its battered surface. And if you're as fascinated by Mercury's secrets as we are, be sure to hit the thumbs up, subscribe, and join us for more cosmic journeys. The universe is full of wonders, and we're just getting started. If space amazes you, hit subscribe. This is Space Lab.